Okay, now we're going to look at some trig graphs, and we're going to go backwards. We're going to find equations of some trigonometric graphs. Excuse the noise in the background. I've got the basketball practice outside my office, so we'll see how we go. Okay, so here's the first one. Now, in the questions in the book, it actually gives you what type of graph it is, sine or cos. Okay, and it doesn't actually have any tan questions, I don't think. So that's something we'll have to look at. But not only does it tell you if it's sine or cos, it gives you the general form that it's in. So if we look at this first one here, okay, it's y equals a sine nx. So in other words, y equals something, sine something x. Let's first of all look at the amplitude, the a, which is pretty straightforward. Okay, so we can see the graph maxes out at 2, okay, and neg 2. Okay, so we know the amplitude is from the top of the wave to the middle of the graph. So that distance is 2. So A equals 2. Now let's have a look at what n might be. N is the period. And if we look at the period of this graph, it starts there at the origin and goes over to 4 pi. The period equals 4 pi. So we might go into the next page with a bit more room and we'll work out what n will be. Okay, period equals 2 pi over n. This time we're working backwards because we're actually trying to find what the value of n is. So we just looked at the period being 4 pi equals 2 pi over n. Put the n on the left hand side, the 4 pi pops underneath. So we get 2 pi over 4 pi. N is 1/2. So our value for n is 1/2. Let's go back to the previous slide. So we now know that a equals 2 and n equals 1/2. So our equation is going to be 2, or y equals 2 sine 1/2 x. And there's the first one done. Here's the next one, and we can see that y equals a sine nx plus c. Here's our graph. So the slight difference between this one and the last one is we've got a shift this time of plus c. Okay, still in the form of a sine nx, but we've also got a shift as well. Okay, so that could be a shift upwards or it could be a shift downwards. And by looking at the graph already, because it maxes here at 2 and neg 4, I can see it's been shifted downwards. So C will most likely be a negative number. Alright, let's have a bit of a look at, first of all, A, the amplitude. So our distance between the top of the graph, the maximum and the minimum, is a distance of 6. Okay, so I measure down there, between the top and the bottom. Okay, that's going to be 6 units. So what we do there to find the amplitude, it's half of that 6. The distance between the top of the wave and half of the wave, the middle of the wave, sorry, would be half of 6, which is 3. So A here equals 3. Let's also look at our value for n. We'll go on the next slide to do that. Our period, by the way, here goes from 0, 0 up to pi. So one full wave goes from 0 to pi. So the period equals pi. So period equals 2 pi on n. The period, as we just saw, is pi equals 2 pi on n. Swap places, n equals 2 pi on pi, n equals 2. So our value for n is 2. Now what's been the shift? Let's write that down, sorry, n equals 2. What's been the shift? Well, usually with amplitude 3, the graph would go from 3 down to neg 3. We've got a graph that's going from 2 down to neg 4. So quite obviously the graph has been shifted down one place. So that means our value for C equals negative 1. It's been shifted down one place. So our equation is y equals 3 sine 2x minus 1. And that's around there, and we're done. Okay, here's the next one, and this is the first time now that we've had the axes in one of our trigonometric graphs that don't involve pi. You'll notice down here on the x-axis, we've got 1, 2, 3, 4, 5, okay, instead of pi on 2, etc. So that's an interesting bit of a change there. We've also got a cos graph this time. The last couple of examples I've done have been sine. Alright, let's consider first of all then what a is equal to. So the maximum here is at 3. Our minimum appears to be down here at -1, there and there. So the distance between top and bottom, 3 down to -1 is 4. The amplitude is half of that, so the amplitude here, the amplitude here is going to be 2. There it is, amplitude equals 2. Okay, just resize that a bit. Okay, so let's look at n. And to do that, we're going to go over to the next slide to make a bit more room. But let's look at our period. The distance for one wave is 0 over to 6. Okay, that's 6 units. So our period here equals 6. So let's go over the page and work things out. Actually, oops, I didn't leave a slide, so we'll just go back and work it out here. Sorry about that. So period, got room over here, equals 2 pi over n. We've got 6, which is the period, equals 2 pi over n. Swap, oops, that's n. Pardon. Let's go back. 2 pi over n. Swap places, n equals 2 pi on 6. So n here equals pi on 3. So it's an unusual value for n, one that we haven't had before, but a legitimate one. There's also been a shift here. Notice the C here is out the front, so it's obviously been shifted. So we've got amplitude equals 2. Normally a graph with amplitude 2 would go from 2 down to -2. We're going from 3 down to -1. So we've had a shift up one place. So C here is going to equal 1. Alright, so what's our graph? We've now got our A there, our N there, and our C there. So our graph will be y equals 1 plus 2 cos, okay, and we've got pi on 3x, so in brackets pi on 3x. Okay, so there's our answer. Let's put a square around it so you can see it clearly. Our last one for this presentation is, you can see the magenta graph there, and we've got, I'll just change colour here. We've got this equation that we're looking for is in the form a cos n outside of x minus, that's the Greek letter epsilon. So there's obviously been a shift here because we've got, the first time in one of these we've got a minus epsilon, okay, and it's telling us it's a cosine graph. Alright, well the shift is going to be the hardest bit, so let's look at the other bits first. And first of all we're looking at A. Okay, so A is the amplitude. Okay, and if we look at the amplitude here, it goes from 5 down to -5, so quite straightforward. Amplitude A equals 5. Okay, N is the period of the graph. The period is pi. Okay, so period equals 2 pi on n. So the period is pi equals 2 pi on n. Swapping places, n equals 2 pi on pi. N equals 2. Okay, so now we've got our A and our n value. There's been no shift up or down, although you can get these ones that do have those vertical shifts as well. But we've now got the situation of there's been a shift to the right, and how many places. Alright, well look, this is a cos graph, but when you look at it over here, this looks like a sine graph. Okay, let's have a look if it was a cos graph, now where it would have started. Now there's always a few options for these, but I'm going to go to the most straightforward one. If I'd moved the graph this direction, okay, let's try and get an arrow going here, sorry about that, let's try again. If I get a movement in that direction there, if I move the graph in that direction there, it becomes a cos graph. The question is, how far would I move it to make it a cos graph? Well, I'd only have to move it to here. If I move it pi on 4 places over in this direction, I make it a cos graph, which would mean I would move the other key points to the graph pi on 4 to the left as well. Okay, and I can just put blue crosses here to indicate that. And I'm moving the whole graph pi on 4 places to the left. Notice here I've put in an extra coordinate, okay, because this graph actually heads back up again and maxes out. If I just change the colour to the original, it would actually max out here at 5 pi on 4 comma 5. So back to the blue colour. If I move these key points to the left, so I've moved that one there at 5, I've moved the one here at pi on 4, I've moved the intercept there, I've moved that one from pi to there, okay, and then I'd move this one from here over to pi. So if I move those and then drew the graph again, like so, I'm actually getting a cosine graph, looking something like this. Goes down to there as well. Okay, it's still got the period of pi. Notice it maxes out at pi and on the axis, but I've moved it to the left. Now, let's say my blue graph was the original one. Okay, to create the graph that we were given, the magenta one, it's been moved pi on 4 places to the right. So the horizontal shift has been to the right pi on 4 places. Therefore, epsilon, this here, is pi on 4. So in these graphs, we look at them, we're told it's a cosine graph, therefore we create a cosine graph, and then we say, okay, that was the original cosine graph, where did I have to move it to create the graph that I was given? Answer, pi on 4 places to the right. Therefore, our final equation, I'll squeeze it up here, change colour to make it stand out, go for red, is going to be y equals, A was 2 cosine, okay, and then open the squarish bracket, n was 2, and then it's x minus epsilon, which is pi on 4. Okay, so the red graph there is our final answer. Okay, that's all for this presentation. Sorry, I just realised I made a mistake and put the 2 there for the amplitude, so we'll just fix that up. And it's actually 5 cos, sorry about that. A was 5. So anyway, that is now the end of the presentation. I hope you enjoyed it. And in class tomorrow, we're going to work on exercise 6F. And make a head start tonight if you've got time. Otherwise, we'll do it in class tomorrow.